involved, and you end up loving like Jupyter Notebooks, and it tells you too many pages are open. No. Well, if you go to your main page, there's going to be a tab that's called Running, and it's right next to the files. And inside of that Running, you'd be able to see all the different pages that you actually have running, and you could actually shut down those kernels that are running. So keep that in mind for the too many pages that are open. So again, sometimes you'll get that. No time to panic. All that means is that you have a lot of kernels opened up at the same time. You can close them as you need to. Your files are still saved, but you can just shut down that kernel and bring them back up and run them whenever you need to. One of the things that happens, in fact, particularly for me, is I use a plugin called Vimium, which I love, but sometimes it gets in the way. And you may have some of these plugins yourself because you want your browser to behave a certain way, or you want certain key mappings, and we do a lot of things to our browser to make it more comfortable for us. But again, sometimes they get in the way. So one of the things you may want to take a look at is like Grammarly. I use Grammarly all the time, but sometimes I have to turn that off. Take a look at whatever application that may be getting your way. Maybe some of these hotkeys aren't working. And if they're not working, turn it off. And then again, it's going to depend on whatever kind of browser plugins that you have. Here's an example from my Vimium plugin that gets in my way too often, particularly when it comes into a Jupyter Notebook. So I may just want to turn that off. If you're stuck, and every time you run a web page, there's going to be a menu item up at the top called Kernel, okay? And this will allow you to bail out of things. Sometimes you'll go to a cell, and you just get stuck. Like, it's just evaluating. And one of the things you'll see is you'll see an asterisk, and we'll have a demo of that here coming up soon when we discuss widgets. You'll have an asterisk there, which means it's currently evaluating. And sometimes it never stops. It's just continually updating. So one of the things you could do is you go up to kernel, and this is the one where I'll use a mouse for it, one of my rare occasions, and I'll do an interrupt, which is, look, I know this cell's been going on for the last minute or so, just stop. And I'll just do an interrupt there, and I'll stop the process. I may want to restart and clear all the output, okay? So what happens with something like that? Remember, we have those ins and outs, ins and outs, ins and outs as your evaluated sheet. But sometimes you end up doing things out of order, and it's kind of a mess. You don't know what you evaluated. You like to start again from the beginning. You have a couple of options. One of them is restart and clear the output, which is just erase everything that's been evaluated. Not your content, but erase everything that has already been evaluated and start new. Maybe you just want to manually go one by one on each cell all over again. In that case, a restart and clear output is the way to go. But you could also restart and run everything. Maybe you don't want to click everything. I just want to just restart everything. Well, I could do a restart and run all or something like that. So those are some keys that I think will help out quite a bit, particularly if you get stuck in anything. All right. Well, let's discuss some visualizations. So having good visualization tells a story a lot better. And excellence in statistical graphics consists of taking complex ideas and communicate it for clarity with precision and efficiency. And one of the best quotes, a large share of ink on a graphic should present data information. The ink changing as the data changes. Data ink is the non-erasable core of that graphic. The non-redundant ink arranged in response to variation in the numbers represented. Above all else, show the data. Don't overshow the visualization. You can get creative, but if you get too overly creative, it tends to obfuscate what it is that you're trying to show. So good visualizations goes a long way because it shows exactly what it is that you're trying to convey. And one of the great packages that you can use and you all will often use with your Jupyter Notebook or your Jupyter Lab is going to be Matplotlib. It is a library which produces publication quality visualizations in a variety of formats. You can have 3D graphing, bar graphs, and lots of varying graphs. It is excellent. And in fact, I think this is really the gold standard that others chase after as far as visualizations, because they have so many graphs and they are very flexible for you to change the way things look, and the values, how they show up. Everything about it is extremely flexible for you to work with. And again, so much of a gold standard. I think there are a lot of notebooks and a lot of visualization tools that are out there. They just don't have all the different features that Matplotlib has. Let's take a look at a demo of how this works, so that way you could do your own visualizations in a Jupyter Notebook. All right, let's head back. So I'm going to go back to the demo on here, and let's make sure that this is looking good. There it is. And I'm going to, if I want to, I'll just shut these down. It may take some time, but again, I can shut them down. They'll close up, so that way I don't have things that are running on the back end. But what I'm going to do is I'm going to click on that blue folder, which should take me to the root. And I'm going to go to Notebooks. And I'm going to open up chapter number 2 here, which is visualizations. And I'm going to go ahead and run this. And here we are. All right. So here we are in visualizations. And what I like to do is walk you through the idea of what a visualization is in a Jupyter Notebook. So I'm going to run these top ones here. These are some imports that we need to do plotting. You know what NumPy is now, or maybe you have already. Here's Matplotlib. So this one is import Matplotlib pyplot as PLT. So we're going to have a prefix associated with that. And then we're going to have a directive here, %matplotlib inline. So that way we can display these graphs inline. And then what I'm going to do is I'm going to do the following. I have this XY, but here we go again. Again, sometimes you're going to end up looking at things, and you kind of want to know what it is that you're looking at. So this is where a Control-Shift-minus is going to go a long way. And let's say I don't know what this A range is, but I kind of want to visually look to see what this looks like. Here it is. So ranges go from 0 through 10, not including 10, and take a step of 0.5 each time. And then I'll get these numbers here. Oh, cool. Now I understand what this A range is. See how great splitting a cell goes? Again, if you're going to be getting material and you kind of don't understand what it is, break it up. Make it easier on yourself. That way you have your aha moment, understand what it is, and if you want to bring it back together again, you can do so. Maybe. Yeah, there it is. Okay, I'll clean that up a bit, and here's the way it looks. Now, if I want to take a look to see, well, what does Y look like in all this? Well, the way this works, particularly in Pandas and NumPy, is that when you multiply by something or bring a power to it, that's what the **2 means here, is that I'm applying, square each number inside of X. That's what that's doing. So I'm squaring each number, and this is what that resultant looks like. Okay? So when you graph, you are dealing with plurals. I'm dealing with a multiple number of X values, which is the range, and you saw there that I'm going from 0 through 10 with a 0.5 step on each one. But the next one, what I'm doing is I'm applying that square to each number on there. Okay? And so if I run that, here's what the plot looks like. One of the things that you'll notice here is that there's a semicolon at the end of this. If I didn't have this there, I'm going to get some sort of result at the end of this, and here's what it looks like. It says a matplotlib lines 2D and junk that I don't need. So a semicolon would clean that up, so that way it looks like this. Okay? And that's what it is. We're just doing arithmetic on and with this X here, just taking a step for each one, and then here we are plotting. And we can do, a plot like this where it's just one continual line that we're looking at. Or we can call this one, which is scatter, right over here. What does scatter look like? Well, it's the same graph, except it's a scatter plot. however you want to express yourself. And this is all lined up in here. Here's a lint space. What is lint space? So this one is, let's do 0 through 10, and then 50 data points in each one. Ooh, interesting. And if you don't believe me, that's fine. Kind of weird for something to not believe in. But if you don't believe me, or you just want to prove it to yourself, again, there are some plugins like a notebook that you can run. So in other words, what your scope is. I didn't talk about scope with a Jupyter Notebook. You probably already gathered this, but the scope, the default scope for any kind of variable that you have is the page itself. Now there are some extensions. One of them is a notepad. If you want to evaluate something over to the side, you can do so. Or you could just split the cell. Here, let me do that again. All right, caught it. Okay, well, here it is. 0 through 10 with 50 data points in between. Oh, that's great. Okay. So prove it to yourself. Nothing wrong with doing that. And if you want, it's always easy to split a cell and merge it. And then here it is. Okay. Different ways to bring in this data. Now, this one's using sklearn, scikit-learn. And that is one of the data science projects that's available in Python. There are other ones, of course. There's TensorFlow, Dask, and a few others. Dask, I believe, uses scikit-learn anyway. But it's a great machine learning package that you can use. And I'm not going to use it here for machine learning, but I am going to use this to load some data. And what this data is the iris data. Now we're getting more into the field of, hey, there's this big block of data in here, and I don't even know what I'm looking at. And I don't even know what this iris looks at. Again, when you're dealing with a Jupyter Notebook, split it. And then take a look at the data. That gives you a deeper meaning as to what it is you're looking at. No penalty in doing it. And we get to see over here the different parts. Well, I could get the data, and this is going to show the rows and columns for that data. And every data is different. Target here is going to be the classification. So this one has some answers. 0 means Setosa, 1 means versicolor, and 2's mean virginica. Those are the kind of irises that we are using. Here are the target names. Here's a description of it and what it is. Here are the feature names. So data scientists will use features to describe the column names. Data scientists have different words for other things that we have. So columns are features. So here are the feature names. So in other words, again, the column names that we're using. So sepal length, sepal width, petal length, petal width. Those are columns that we can use. And I may want to tap into this. So I want to tap maybe into feature names because that would look good on a graph for labels. Maybe the target would be good because I want to change the color and the way the data points look. And of course, I may want to plot whatever the data looks like. So all the data is in here in this object called iris. If you're not familiar with Python, Python is object-oriented. It has attributes, so I can just treat this, I can just say iris data to say, give me the data. I could say iris.target names to give me the target names. I could do iris.desker to give me the description of everything. So I could tap into this. And I can tap into this to form, some graph. And so what I like to do here is I would like to, take that data, pluck things out of it, and I'd like to create an x-axis, and I'd like to create a y-axis. What is this one here? Well, this one is get me the data, and this colon here is get me all the rows, but get me everything from the first column. And again, if you want to verify that yourself, split the cell. Nothing wrong with doing that, and just put this here at the tail end. and you get to see this here. So these are what's going to be plotted in the x-axis, okay? And there it is. And if I need to merge it, I can do so very easily. Here's the y-axis. Y-axis is get me everything, go to the data, which is going to be the presentation of the data, but get me everything on the second column. What are the column names? Well, remember, inside of Iris here, there was a section called feature names. I want to get that first one because I want to make that the column name. Here's the other one, and here's the column name here. And target is going to be the colors. What kind of iris is this? What is the categorization? Are they versicolor? Are they setosa? Are they virginica? What are they? And so I want to evaluate that. Any questions on this? Again, when it comes to data science or the engineering or using a Jupyter Notebook, you'll be thrown a big chunk of data, and you'll just be like, all right, here we go. I want to use that big chunk of data, but you're going to have to pull out the parts that you want, particularly for plotting. There it is. And all of those data points, are going to be the data points that came with that big chunk of data. And you get to plot them very easily when you tell your story with a Jupyter Notebook. But there's more to it. Let's go to this cell down over here. And again, you can run these demos yourself. I can put a X label and a Y label. So what is it that we're looking at? Well, we're plotting the sepal length, which is just a dimension of an iris. And we're plotting the length and the width together. Cool. Maybe I want a title to this graph. I don't see a title here. Let's try the next one, which will bring in a title. Great. So what I'm going to do is I'm going to bring in iris data set, sepal length, and sepal width. That's the exciting part because you're going to be getting data, and how do you wish to manipulate that data? You could do so with a graph like this. Here's another one. Let's see, what do I want to do this time? Oh, yeah, look at this one. This one is C target. What is target? Oh, well, target is going to be whatever the answer is. In other words, for each data point, is that data point a setosa, a versicolor, virginica, which are types of irises? Think of it as like maybe, weather as classification, cloudy, clear, partly cloudy. All those are categorizations. Like in a graph of data, what color do you want that to be? And we're going to plug that in. So either one of these data points has a classification associated with it. And when I bring that up, here's what it looks like. Purples are, I believe that one's a setosa, and versicolor and virginica are kind of like mixed up with one another. But each data point had a classification associated with it. So we have a particular color associated with it. Isn't it great? Again, you just get a lump of data and it's going to be your thing to pluck out the essential elements that you need. I can change how big the figure size is. I could also add alpha rendering. So maybe some things would look darker than some of the others. And alpha rendering, if there's overlap, they get darker, but if they're separate from one another, they're lighter. So that way it makes, visualizing clusters a little bit more pronounced. That's great. And, I already had the labels for that. So it's easy to construct these kind of graphs together. I can also add color maps. So, maybe winter is coming. So here's a nice winter color for that. Okay. This one's using Seaborn. So Seaborn is another layer, another visualization that you can use along with Matplotlib. And they have things like anti-aliasing, nicer looking graphs, and a few other things. And you could set a style with it. In this case, I'm going to use that SNS or that Seaborn to change what the grid looks like. Let's run this one. Look at that one. Okay. Smooth anti-aliasing, smooth rendering, and I get to have like grids along with it. So I get to make some even better outstanding graphs using Seaborn. If you want to know more, take a look at Seaborn for all the different kinds of graphs that you can have, heat maps, and a few other things. Like I said, this group is miles ahead from anybody else for a lot of these visualizations, and a lot of them are trying to catch up. Let's take a look at this one. What's the difference on this one? Let's see, we have the figure size. I think this one we're setting it to dark mode, I think, and that's it. So here's what the dark mode looks like. So you can change a lot of different kind of settings. Let's see, on this one we have winter, dark grid, 10.5. Oh, this is dark with a grid. So we get to see the little white in here. Okay, so change the way that looks. Oh, I can add tick marks. So this one is bring on the graph, but I'm going to set a style of tick marks. So that way I have tick marks underneath. And here they are. I have nice little tick marks for both the X and Y. Now, what happens if I have a single axis? Like this is a 2D graph, right? I have sepal length, I have an X and Y that they're being plotted here. But what happens if I want to plot things, in one dimensions? I could do that as well, and all that means is that the column is 0. That's what that is. So in this case, I want to, oh no, it's not this one. It's the other one. It's this one. So this one is, get me the first column of data. I want to plot that. But when it comes to the y-axis, what I want to do is I want to fill it up with a bunch of zeros. Everything is 0 on the y-axis. The x-axis is what I'm going to show. So here it is. Cool. If I want to show one-dimensional data, aka one column, I could do so. I just need to make sure that y is 0. Okay? And in fact, even from a machine learning perspective here, you could see that, hey, if I just draw a line right here at 5.56, anything before it is probably Setosa, and everything afterwards is something else. But if I wanted to identify data-wise, everything that is a type of Setosa, I could do that in a one dimension. It's not even really machine learning. It's plotted in a one-dimensional graph, and if that value is less than 5.6, I've already classified something. Cool. Well, that was easy. Okay. Let's take a look at this one. Okay. You've probably seen this quite a bit. Particularly, one of the interesting things and bummer things has been like we've been involved in a virus, and you've probably seen lots of graphs. This one would be, let's say, I have buckets, and how many countries, had with the number of infections that they had, right, would be something that would be in a kind of like a histogram sort of look, or a distribution kind of graph. If you play Wordle, you've seen this kind of graph. When you take a look at your statistics, after you're done, it shows, the distribution, how many games have you played where you guessed it in 0, or, in 1 or 2 or 3 or 4 or 5. That would be something that you could do as well. So on this one is a histogram. Here it is, HIST, which is a different kind of graph that you can use. So these are all, the data for 4.5, for 5.0, for 5.5, and how they're distributed across. Okay. You can put them into smaller bins if you want as part of the histogram. Okay. And you can get pretty fanciful with this. So on this one is an example of alpha shading, where, and you'll notice right over here, here's a overlap between the sepal length and the sepal width, a little bit of overlap, but most of the width is on the left-hand side. Most of the length is over here on the right-hand side. Okay. So the thing about, any kind of machine learning, if you want to take on that endeavor, is that there's a lot of visualization going on, because as humans, you want to recognize things. And visualization will go a long way. Here's another one here. So this one is taking other particular columns. This one's the petal length and the petal width. and we see that there's a mix-up somewhere in the middle here for some of these. And again, you're just looking at data, seeing if you can hook on to something. And here's a box plot chart, which shows the averages, the medians, and where most of the data is located. Within the box, that's where most of the data is located. Everything outside of that is considered an outlier. And the bars that you see at the end are your min and max. So you can generate kind of like a lot of information from these box plot charts. So you can see here that the sepal length, most of the data is between 5 and maybe 6.5. There are some that are less than and greater than that as far as outliers, but most of the data is going to be within there. And as far as the average, the median and the mean, they are close to one another. Okay, so you can extract a lot of information using these box plots. Things that are tighter tend to kind of convey that most of the information is in here, and it's probably, if we do a distribution graph, it's probably going to be very spiky if it's really small in this kind of square graph here. But things that are really large, like the petal length here, that graph distribution is likely going to have a very small plateau because it's very wide in the way that looks. So you could extrapolate quite a bit from these particular visualizations. Okay. Anyway, let's give this a try. We have another exercise here. Let's go over to the labs. Again, you could lean on the solutions if you'd like. Get some more information on that. But here it is. You're going to get the characters again. Import Seaborn, and I already got a lot of these. So you would just fill in the last 3 values in here to display a bar graph. Oh, cool. So this bar graph would be, which houses are each of the Harry Potter characters. All right, give it a try. And again, if you need to lean on the solutions, they are there as well. Okay? All right. I'll have you go for it. And if you have any questions, please let me know. know how it's going. Maybe about 3 more minutes. 'Cause I think you have like maybe 5 lines to add here, but it's unfamiliar to you, so I get that. So if you need more time, let me know. But I did all the code cleanup here for getting the characters' value counts. You just have the x-axis and y-axis just ready to go, ready to be plotted in. This one's going to be a little bit different in that you're using a PLT bar. Here you'll do your imports, and here's the data frame, which you already know how to do from the last lab. Bring that in, and then run the PLT bar, and then you're good to go, and you'll be able to see how that looks. Or I think there's also an SNS bar that you could try as well. And we'll take a look at the solutions. I think there's SNS bar. Either one, you should be able to plug that in. Right, how did it go? Anybody need more time? Let me know. Just tell me on the chat. 1 more minute, please. 2 more minutes, please. And I think there was like minimal lines. All you had to do was bring in that bar. Or let me take a look at the solutions here for this one. Yeah, here's the CSV. And this one was a separator by a semicolon. So keep in mind in that, again, remember, data's different. Sometimes they're separated by commas, sometimes they're not. Here's the imports. You can just copy that from the demo. And then all these were available for you. You just had to run these. So here's the x-axis, here's the y-axis, and then here's the a way that you could go about it. So you could do a PLT bar. And then, this one's SNS bar plot. So either one of these you could run. And here shows some examples here. So if you need help with anything, let me know. Take a look at that. But yeah, Seaborn has their own different plots as well. And let me run that one. Here, I'm going to run all the kernel here, and I'm going to run them all. And run all the cells. Here we go. Just so that everything's evaluated. There we go. Ooh, I got a warning on that one. I'll have to figure out what's going on there. I bet usually I have to have this now, like x equals or something like that. But yeah, x is equal to x-axis, y is equal to y-axis. Should get rid of that warning because they want things to be a little bit more specific now, and that's what it is here. All right, yeah, but this one has a white grid. Both of these look really good. Again, I did most of that cleanup for you. That's just the object, grab things, grab the columns that you want, set them up. But yeah, more characters are from Gryffindor, for example. So, and you can make whatever kind of visualization. Cool. You probably saw value counts. Value counts does a grouping already. So, however you want to grab the information, manipulate the information, that's what a value count is. It's really like a group by plus count is what a value count is. But yeah, I think all this looks fantastic. Let me know if you have any questions. And we'll go on to widgets. Like how do we make things more exciting and interactive in our next section? All right. Well, I'm not going to go back to the slides because I'm just going to jump right in and talk about widgets next. All right. Well, I'm going to go to the root page here. And what I'm going to do is I'm going to click on that root folder now. And what I am going to do, let me close some of these out here, see what's running right now. Boy, they just keep adding up. I don't think the introductions were ever shut down. Hopefully that doesn't disrupt anything. So let me come back here to the file. And I'm going to go to notebooks this time. And what I want to do is I want to demo the widgets. Let's take a look over here. All right, so graphing's great. But what if, whatever notebook you have, whatever kind of solution that you have, you want to make this interesting and interactive for your end users to appreciate and enjoy, because they may want to change a certain variable, and from that we may want to see how this looks, how this interacts with one another. And that's where an interact comes in, and some of its variants from it. The interact function automatically creates kind of like a user interface for us with UI controls that we can manipulate how things are done. So it auto-generates a UI based on function arguments. And in this case here, we're bringing in that import statement. Let's take a look. So this one is, we're going to bring in widgets, and we're going to bring in the function interact. And this is going to change the way our Jupyter Notebooks look, work, and feel. So for example, let's take this power squared with this x. And what we're going to do is just square that. What happens if I shove this function into an interact? Well, this power squared is requesting an argument called x. And this interact here, I'm going to say x is equal to 10. What interact will do, well, let's bring in this function here, so that way it could be evaluated. This is just going to be a regular Python function. But what I could do is I could bring in an interact, and when I run this, all of a sudden I have this widget that I can use. And whatever gets resolved will be printed right down here. So now your end users are able to do the following. I'll move up and down. Okay? And that shows over here. So 26 squared is that. If I maximize over to 30, I get a 900. This could be customized. The min max can be customized. The step could be optimized as well to your liking. But not only is this going to be static data with static graphs, you can change the way that looks, from that page, and have your end users interact with your data. Now, here's another one. So this one is interact, power squared. So in other words, call that function, and I have a min, I have a max, and I have a step. So every time I move the knob, that's going to move 10 in each direction. Let me go ahead and run this so that way we could see this highlighted here. So right now this is 40. But if I move a little bit to the left, oh, look at that. I don't have any choice. This is 40, 50, 60, 70, 80, 90, and 100 in either way. Why 100? Because I specified that that was the max. On the min, this could only go to -10. Why? Because that's what I stipulated here inside the x. This one is using a tuple inside of that x. set the min, the max, and the step for that power square. But again, you're giving your end users more flexibility. That way they can move the knobs and make decisions based on it. Here's a function h, which brings in a p and q, and I'm just going to return that as a tuple back. Let's take a look at this one. So the function is h. P is 5, so we're going to have a range of 5. But Q is using a function called fixed here. What is that going to be? Well, that means that Q is always going to be 20. That's what fixed means. But P is going to have a range. And here's that range here. So again, if you want to, have one number that's fixed, set in stone, but the other one is flexible for that your end users could try themselves, you can do that as well. Now, if you really, really, really want to be specific, one of the things that you can do is you can call interact with power squared, and where we plug in x could be this right here. So this is a very explicit mode on how we want to do it. The min is -10, the max is 30, every step is 1, and the initial value is going to be 10. Okay? So given this compute here, I can interact with it. Let's see what this one looks like with a slider. It's the same thing, except the API is just a little bit more explicit in how that works. Now, if the keyboard, or if the key argument, so we have the power squared, and if this right here is a tuple, or if it is a number, or if it's something else, maybe a list of elements, you'll get something in return. Different. So in other words, if this x here, let's come up over here. Before I just had a number, a single number. Or I can have this as a tuple. Or I could have it as, a list if I wanted to. Depending on what this is that I have highlighted here, you're going to get a different result from it. And so that means right over here, if the argument's true or false, then you get a checkbox out of it. If you have a tuple, then you're going to get an int slider for an integer number. But if these numbers are a float value and this is tuple, you're going to get a float slider. But if you have a list element like red, yellow, and orange, or a list of tuples as a list, like an associative array, then you're going to get a drop down. So depending on what it is that you feed to it, then you'll get a different result from it. Let's take a look over here. So here's a compute with x, y, and z. And I'm going to feed it that compute. So x is going to be 10, which will be an int slider. Y is going to be an int slider as well. So that'll be the max, that'll be the min, and the step will be 2. But z is going to be equal to true, so that should render a checkbox. Let's take a look. There it is. So if I want z to be evaluated as a Boolean, I could check that one on and off. This one's a different kind of slider with a step of 2, and this one's a more fluid slider because, I just started with 10. So you could just specify how things look for your end user. Okay. Now, interactive. So interactive is a complement to interact, except what this one allows you to do, it allows you to reuse your components. Okay? So the return value of the function will not be displayed automatically. You have to plug that in using a display. Okay? And you'll also be using display twice for displaying the value and displaying the widget. Okay? We have more control over it. Let's take a look at one of these here. So here's a myAdder, which says the result of D and D is equal to D, where we're plugging this in. This one's using a display, and what we're going to return. So this one's going to return a textual display of it. Now this one is interactive, but what you'll notice here is that interact by itself, it's kind of like a procedure. It's not really a function. It's kind of like a procedure that it does something, but you get nothing in return. But one of the things you'll notice here is that with interactive, you're definitely getting something in return. because it says here W is equal to interactive. Now it's up to me to decide when I want to call display. But notice this time, I'm displaying the widget. Okay? So let's run this. And nearly the same thing, except we're just treating that interactive component, like an object where I can decide where to place things. And I get to see the results right over here. So a little bit more control for using an interactive. And for each widget that I create, that holds on to a particular state. Isn't this interesting here? Because I have, if you take a look above here, A is -3 and B is 54. Well, that's a state because that's the widget. That's the other great thing about using interactive instead. And it holds the result. So right now, -3 and 54 is equal to 51 because I'm just treating that object like an actual object, an object-oriented programming, where I have that particular step. Take a look at some other cool items here. Here's a manual interaction. What I'm going to do is I'm going to call this directive. So sometimes with a Jupyter Notebook, and particularly with Python, you have a directive called time it, and a few other directives are out there, which changes the way that a notebook behaves or how an execution of code behaves. Time it is a way that you could do a benchmark on a particular function call. So what I'm going to do is I'm going to go to sleep for 2.5 seconds. When I call this function, I'm going to say, given a value of such and such, I'm going to go to sleep for 2.5 seconds, and I'm going to time how long this takes. So here's the function, and now I'm going to run it. Given a value of that, slept for 2.5 seconds, I return 1 million from it. Now, time it is going to run this multiple times. And then what we're going to get out of it is we're going to get the average with a plus or minus deviation from that particular average. And there it is. So on average, everything took 2.5 seconds with a deviation of 8.23 microseconds. So again, nothing's really exact, but we're looking at the mean and the standard deviation after 7 runs, 1 loop each. Okay, so great for a little benchmark. So we get to see how long some takes. Now let's take a look over here. I'm going to run interact with these values, and here we go. But notice what happens because this is a slow function here. And if I try to move that, particularly if I'm moving it really slowly, notice what it's doing. Because this function takes a long time, it's recalculating every time I make a move. Well, maybe I don't want that. In that case, I may want to use a interact manual for this. And an interact manual would be, finally when it settles, that's when I'll calculate it. Same slow function in here. Let's give that a try. So, oh yeah, and I forgot, this one has a button. So I can move this willy-nilly, and it's not going to run a 2.5 second calculation every time that I run this. I move it to a place where it can settle, and then I can run interact, and this will say, given this value, then I'm going to go to sleep for 2.5 seconds. And I only calculate that once. I don't calculate that multiple times. This continuous update here will only stop, and take a look here with this continuous update. This will only stop when there's no more mouse movement. So I'm going to move it willy-nilly, and notice no calculation is happening until I let go of the mouse. Done. And now it's going to do evaluation. Okay? That's called a continuous update false. In other words, don't continuously update this over and over. Cool. So I can put things, and this is where you can get stylistic. It almost very much looks like a CSS. In fact, sometimes it does use a little bit of CSS. But you can put things in a horizontal box, for example. So if I want a nice little panel down below, like an instrumentation panel on how things look, I could do so. So here I want to move that, I want to move that, and I want to move that. Okay? And you notice here that I have these results here. So you can make it as beautiful as you'd like. and they would all change the way something behaves. Here's a link. So you can draw a link between two components. So let's say I have a float text and I have a float slider, and I want to display both of those, but I want to link A and B together. Take a look at what this one does. So if I change this value here to 400, is the max 100? Maybe it is. So here I'll just make it 20. There it is. The bottom one is equal to 20. But if I move this one here, here's 62.5 and here's 62.5. So if I want two widgets to be equal to one another, then I can do so here. If I want to make this more front end, I can use JavaScript for this. It's the same thing, but it's likely going to be speedier because it doesn't have to go to the back end kernel in order to render. I can use LaTeX as well, of course. So I can bring in mathematical formulas if I need to. I can create labels with these mathematical formulas as well. And some interesting things that I think you would enjoy would be like date picker. You have calendars, so whatever you choose here can be a part of that date. I can choose colors. Lots of different widgets that you can work with. Can you imagine now, like, in this 3-hour course we talked about just, the basic stuff, using Markdown. Using Markdown, using code, but then also drawing graphs and interacting with your page using these widgets, which just makes great ways to describe things. You can have width, you can have height, you can take a particular layout and reuse that layout for other components. What happens if a description is too long? So this one says a too long ... You can change the style of it and the width of it and how things look. Here's a label and a int slider, another way that you could go about it. We have things like box, horizontal box, vertical box. So you can do some pretty outstanding things like this and line things up in a certain way that people can select buttons however they'd like. You could even use a flex box, which uses a CSS as well. So again, you can make things look however you would like, change colors, change width, whatever it is that you need using this. And thus making your Jupyter Notebooks highly interactive for your end users. Questions on this? All right. Well, we're running out of time, so let's just take a look at, and you can try this yourself if you'd like. And I think you have access to these pages if you're on O'Reilly anyway, and you're logging in. These Katakotas should be available permanently-ish or a while. But what I want to do is I want to do the following. Oh, yeah, I want to go over here, and I want to go to solutions. We'll just take a look quickly at a solution for a lab that we don't have time for the widget. But let's take a look at this one here. So this one is some data using some geographical data with populations. I'm going to run this one just to show you like all the amazing things. Like I am really bringing in data from some source that's out on the internet. That's the population data. And I want to clean up the population. So a lot of these are, categories. Like I think one of these is Europe. And, some of these are just regional. I want country, so I want to remove all of these. And that's what I'm doing here. So I'm just doing some cleanup here. And this will be the population. But then what I want to do is I want to group by the country code and the value for the population. Let's take a look over here. There it is. And then what I want to do is, take a look at this. So this is really more pandas than it is of a Jupyter Notebook. But sometimes what you want to do is you want to get information from somewhere else and join that information. So on here, what I want to do is likely what I want is I'm going to end up grouping things by the continent. Well, this original data didn't have that. Like, it didn't show what continent they belonged to. So in this case here, I want to grab the continent and whatever the code is. So that way I could merge those two together. And that's what I'm doing here. Group the population data and the continent that they belong to, and drop any, data that's missing. And let's set up a method that is going to show the top number of countries with the highest population per a continent. Now, all this was set up. And if I take a look here, everything is set up, and I have the what's kind of weird is I don't know where North America is. I just realized that now. Like, where is North America? Asia, Africa, Europe, South America, Oceania. Doesn't exist. This is an old map. Anyway, I'm not sure what happened there. So I am going to run this, and you can run this as well. If I take a look at this exercise here, this one is the drop down, and what I'm going to do is going to have this interact here. All right, a little bit of a warning here, but I can change where all of these come from. So if I want to change this to Europe, now what's happening here, what it used to do is it used to just overlay this. For some reason, this one isn't. But given this, you should be able to change, the continent that you're wishing to use and do a top K. So maybe, I just want the top 6. Where's top 6? There it is. So I want the top 6, for it, and that's going to change the layout and the graph that I want to look. So you even bring in a graph as well and make that interactive as you. Okay. So some pretty amazing stuff that you can do, and you tie all those in together: the visualization, the widgets, and whatnot. Okay. Bring in data from wherever.